Determining the range of a function requires a slightly smaller skill set than determining the domain of a function. That is because most of the work in finding the range is done by looking at the graph of a function. The range is a little bit more difficult to determine algebraically. It usually requires us to have a pretty solid understanding of the domain. And in those cases that we can't find the domain easily, it's not necessarily that simple to convert that over to finding the range. Fortunately for us, there are a few little things that we could keep in our back pocket aside from just looking at the graphs that would help us determine the range. First, when you're looking at a linear function, you can assume that the range is going to be all real numbers. Because you have that versatility in using anything from the real number set to find in the domain, you should anticipate that you could find any one number to match whatever range value you needed. So the domain and range for the case of the linear functions is all real numbers. Just as a reminder, we write the interval notation for all real numbers as negative infinity to infinity. Be sure not to include those hard brackets at the end because we never can reach infinity. In some of the other cases that we graph, determining the determining the range algebraically would be pretty difficult. However, we can use what we know about transformations and moving functions to help us determine the ranges of some of these key graphs. So take, for example, this absolute value graph right here. This is one of the absolute value functions that we would have looked at. Here's a slope change, here's a move to the right, here's a move down. If the original absolute value parent function was centered at 0 with its vertex and had a range of y is greater than or equal to 0, if I move the graph to the right 3 units, I should not anticipate that that would contribute any change to the range. All I did was move it to the right. I should also anticipate that any changes to the slope isn't going to change the range. The changes in the slope will just change how fast I reach all of those values. The only transformation that's actually going to move the range is the transformation that moves the graph up or down, the translation in the vertical direction. Because I move the graph down 6 units, I am now starting where my y needs to be greater than or equal to -6. If I want to write that in set notation, I do go set in interval notation. The interval notation is -6 all the way up to infinity, again, not reaching infinity. And then our set notation is y is in the real numbers such that y is greater than or equal to -6. And that's all because of that vertical translation down that shifted the entirety of the range down. A parabola behaves in much the same fashion, but its vertex is a little bit more challenging to find. You'll see that this vertex also ends with -6. But if you look over here at the graph, that's where the y-intercept is, not where the vertex is. That's a product of how the quadratic is formed and the squares that are involved in graphing it. So when we look at the graph of a quadratic, we can't just jump right to that transformation. There's a couple other little things happening in here that we would need to worry about. But certainly if we can see the graph, we know that the original parabola, which was up here, has been translated right and down similar to the V. If I can identify where that point is, and it looks like I can, then I know that my range in this case would be y is greater than or equal to -8. Granted, it's not the exact same translation change that we saw in the absolute value, but it's very similar. And I could write the interval and set notations in a similar way. Lastly, I come upon the square root function, which has that unique characteristic of only existing in one quadrant when you graph its original version. Because I shifted this 3 to the left and down 1, again, like the absolute value, this isn't going to matter so much to the range. If I move 3 left or right, I'm still going to reach my same highest point. It's this number, the translation up and down, that does that adjusting for me. So because I moved the square root function down 1 unit, I now have a range of y is greater than or equal to 1. The regular old square root, I was only getting positives out of that. But because I shifted this down 1 unit, and you'll have to excuse me, it's supposed to be y is greater than or equal to -1. Because I shifted this down 1 unit, I now have a range that has a few more possibilities in it. And again, I'll write that interval notation, -1 up to infinity, or y is in the reals such that y is greater than or equal to -1.